I'm talking about properties. And let's start by reviewing the 4 fundamental properties and their most common standard references. See if you can do that without looking at your notes. Tell the person next to you. Okay, so you should have said time, mass, distance, and charge. And time is seconds, distance is meters, mass is kilograms, and charge is coulombs. So area, so the question is area fundamental? No, it's not. It's not in our list of the 4 fundamental properties. And so that means that area must be based on or built upon one or more of the 4. So is area based on mass, distance, time, and or charge? So what is area? So think about that. Area is the measure of the amount of 2-dimensional space. So for instance, we would be measuring how much space is the screen right here. So if area is the amount of 2-dimensional space, say on the screen or on a flag or a wall, then what of the fundamental properties are involved in that? Is mass involved in that? No. Time? No. Distance? Yes. Charge? No. So how is it that we build area from distance? Well, it's actually distance in one direction and distance in another direction. So it's basically distance taken twice. Okay? And so that's why, since it's distance taken twice, we have standard references like inches squared or meters squared or millimeters squared. So you can take any distance standard reference, inches, kilometers, miles, yards, and by squaring it, you have a standard reference for area. So what exactly do we mean by this? So let's talk about, say, meters squared, or meters times meters. That's how we get meters squared. So that's saying we're talking about meters in one direction and meters in another direction. So 1 meter here and 1 meter here. And so why is it called meters squared? Well, if you take a meter in one direction and a meter in another direction, you're actually defining a physical square. So 1 meter squared is the amount of space taken up by a square that has a side length of 1 meter. So 1 meter by 1 meter makes a square, and that's going to be our standard reference. For a standard reference for area based on meters would be meters squared. So rather than meters squared, rather than that, I want to call these, or so meters squared, I want to call these meter squares, because that's what they are. They're squares that have a side length of a meter. So I drew what was a meter square. Let's draw that again. But obviously that is not a true meter, right? So here's a meter square, but obviously that's not true meter. So what I want you to do right now is in your notes, I want you to draw a truly accurate inch square, centimeter square, and millimeter square. A foot square would be too big, it wouldn't fit on your paper, but all 3 of those. So you can pause the video and Desiree will walk around and see if your squares that you've drawn are accurate. Okay, so hopefully you got those. So let's talk about measurement, right? So I got a billboard here, okay? And I want to measure the area of this billboard. So that's just an optical illusion. This is actually two-dimensional. This is the way it's painted. It looks like this car has sticking out of it after crashing into it. So we want to measure the total area of this billboard. And so how do we measure the area, right? So measurement is always by what? Comparison to a standard reference. So what's our standard reference? Well, we just said our standard reference would be like 1 square. So I'm going to actually take meter squares. So this is a meter square. And so measuring the size of this billboard, its area, is a matter of comparing it to this 1 meter square. So obviously it's bigger than a meter square, so by what times bigger is it? All right, so what I can do is I can start laying a square like this, and lay it in the corner there, and then take another one, and lay it next to it, and again. Like this, and then it looks like, I'll do one more. Maybe that is like a quarter of a square. It's going to actually cover the red. Okay? So, and then I would continue doing this and continue laying these squares on top of the red surface so that I know how big the billboard is compared to 1 meter square, right? So these are truly, relative to this billboard, this is truly a meter by a meter, okay? And so I can do that a little faster here if I just grab all these down here. So I'm gonna grab all these rather than do it one at a time. So notice what I've done here. So now I'm trying to cover this with squares to see how the area of the billboard compares to 1 square. All right, and so how does it compare? Well, I can come here and start, what? Counting them, right? So I'm just basically measuring area. So here's the whole ball of wax here. So if I want to know how the size of the billboard compares to 1 square, what am I going to do? I'm going to count how many squares cover it, right? How many squares cover that area. So, okay, so measuring area is about counting the number of squares that cover the region. So here we go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 26, 28, 32, 36, 40, 44, 48. So 48 whole squares. And then what do we say down here? These are like quarter squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each of those is about a quarter of a square. And what about here on the right? These look like about half squares, right? 1, 2, 3, 4 half squares. And then there's this little bit down here. What is that? That's like a quarter of a half, right? So if it's a half this way and a quarter this way, it's like a quarter of a half, or it's like 1/8 square. So here we go. If we want to get the area, then we're going to do 48 plus 12 quarter squares. So 12 times 1 quarter plus 1 times 1/8. If we want to count the number of squares, I counted 48 whole squares, 12 quarter squares, 4 half squares over here, and then that one little one here is a half of a quarter or an eighth, so 1/8 square. And so we get 48 plus 3 plus 2 plus 1/8 is 53 and 1/8 what? Square meters, or meter squares, right? Meter squares. So what's the size of the billboard? Again, it's 53 and 1/8 times as much as 1 meter square. Right? It's 53 and 1/8 times as much as 1 meter square is that area. Okay, so what I want you to do now is I want you to take out a blank sheet of paper, 8.5 by 11, standard sheet of paper, like this. And I want you to grid it out as accurately as you can into inch squares. So standard sheet. Should draw checkerboard of inch squares. So I'll just let you know that it's 8.5 inches this way. Right? So this way you're going to have eight vertical lines, and then the last one's going to leave about a half an inch. So you're eyeballing it. Don't use a ruler. You're trying to eyeball, trying to create a grid that's going to make perfect inch squares. And then your vertical dimension is 11 inches. Okay? And so then you're going to draw the lines and be careful, be systematic, so that you get 11 perfect inches in vertical rows. And then when it's all said and done, so I'll just draw a few here. When it's all said and done, all those squares in your paper should be as close to an inch by an inch as possible. So it's going to take a little work, but I think it's a good exercise to really be thinking about how is it that we measure area, right? How is it we measure area? And then once you have that whole grid done, I want you to count up the squares just like I counted up these meter squares, right? So I want you to count up all the inch squares, and then that will tell you, once you count up all those squares, it'll tell you what the size of your paper is compared to 1 inch square, right? If you count up all the inch squares. Okay, so pause the video and take some time to do that. Okay, so if you've made your grid correctly, you probably realize very quickly this is a very tedious task to sit here and count every one by one. And hopefully many of you realized a faster way to do that. Okay, so I'm going to come back here. I'm going to come back here to the billboard example. And so rather than count out all these 48 whole squares, what could you have done? Well, you have a grid that's 4 squares this way by 12 squares this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. So how can we quickly count up how many squares those are? So hopefully you realized this, or you even did it when you were counting up your inch squares on the piece of paper. So we know that that would be 4 times 12 to get our 48. Now that's the whole squares. But even better than that, we could, instead of just going 4, we said this was a length, a quarter, right? A quarter of a length. So we could say that the whole dimension is 4 1/4. And this whole dimension, all the way to the end, is 12 1/2. And we can use the same idea of multiplying 4 by 12. That would be this, what I'm showing in green right now. To get the whole billboard, including that extra little red there, we can do 4.25 times 12.5. And that's still counting up the total number of squares it would take to cover up the whole billboard. And when you do that, you get 53. So you should do that. Do that in your calculator. Do 4.25 times 12.5. And what you get is 53.125 meter squares, which is the same thing as we got before when we counted them group by group. So that's why the area of a rectangle is what? Length, in this case height, but I'll just call it width, is length times width, because if you take the length times the width, what that does is it counts up how many squares would fit in that whole area. So all the green whole squares, including this red part outside of those whole squares. Okay, so that's what our formulas do. Our area formulas actually truly count up how many squares of size, whatever unit, so we got 12.5 meters this way, 4.25 meters this way. So the formula is a quick way to count up how many squares would cover the area. Because you'd much prefer to do this, 53.125, than the way we did, or counting them up one by one on your paper. But so we can use that formula as long as we know what that formula does. And that's what it does, is it counts up the squares. So same thing with your paper. Rather than make this whole grid and count up every single inch square, that's a really good exercise to help you remember what area is all about. But the area can just be calculated simply as 11 times 8.5, and that counts up the squares. And what is that? That's 88 plus 5.5. Is it 93.5 square inches? Inch squares? Okay, so that's why the area of a rectangle is length times width. That formula, in effect, what it does is it counts up the squares that would cover your region. Okay, so we've seen that the area of a rectangle is length times width. So what about a triangle? So if I create a line here from that top left corner down to the bottom right corner, this would make a triangle right here. I'm including the red down there. So this triangle, do you see that triangle cuts the billboard exactly in half? So therefore it's 1/2 length times width. But now the length we could call what? The base of the triangle. And what I called the width before, the height. So the area of a triangle is 1/2 base times height. Why? Because it's 1/2 of the triangle, or 1/2 of the rectangle that you get by length times width. But again, this is still counting squares. That formula is a fast version of counting how many squares it would take to cover up that triangle. And it would be the same number of squares as half as much that would cover up the whole billboard. So let's look at another example, and that is for the area of a circle. Okay, so we could do the same thing. We could pick inch squares, or we could pick meter squares, or centimeter squares, or millimeter squares, and try to figure out how many cover it. But I'm going to do something slightly different here. So we know that the radius is the distance from the center out to the edge. So that's the radius, that distance right there. And so what I want to do to measure the area of the circle is not use like inch squares or meter squares or centimeter squares, but what I want to use is radius squares, or I'm going to use squares whose side length is the radius of that circle. Okay? And so I have a square like that right down here. So this is, for this circle, this is a radius square. So I could set it right here. And its side length is the same as the radius. Something like that. Okay, so the question is, how many of these radius squares would cover the circle? So certainly more than one. Okay, so certainly more than one. So I'll make another one. And I'll put it there. And we would say, so all of this area in those two squares is still less than all of the region that's light blue. So let's do another one. Here we got another one here. Okay, now so what do you think? Do you think that all of this area in 3 squares, so these 3 squares, is less than or greater than the area inside the bluish circle? What would you say? Okay, so the actual answer is that this is not quite enough. So these 3 squares, if you were to say cut off this white triangle and this white triangle and this white triangle, it wouldn't quite fill up this remaining quarter of the circle. Those 3 white triangles there would be less than this last quarter that we still haven't covered up yet. Okay, so paste another one, but this time I'm going to show you about what you would need. So what you would need is about this much more. Okay, so what this turns out to be is 3 plus a little bit more. It's actually this little bit more of 1 square is actually 0.1416 of 1 square. So it's like about 14% of 1 square, that little extra right there. And what kind of squares are these? These are radius squares. All right, so what is 3 plus 0.1416? Actually, this is an approximation. Anybody recognize that number? You're right, it's pi. So pi times how many radius squares? Pi number of radius squares makes the area of a circle. Okay? So if your mind is blown right now, you're awake, you're paying attention, because that is super cool. All right? That's where the formula for the area of a circle comes from. Pi is actually counting how many of these radius squares would cover the circle. If we were to chop them up and reposition those pieces, you need 3 plus 14% more, 0.14159, blah, 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 of 1 more square. And that's actually pi number of radius squares is the same as the region inside the circle. And that's where the area of a circle formula comes from. Okay, so hopefully you made it through all this whole video and by the end of class, and if you're done early, then we're done for the day. And your quiz on everything we've covered so far, the homework, and maybe a little bit on area, your quiz will be tomorrow at the start of class on Friday.